So once again, with physical weathering, we're just breaking large rocks into smaller rocks. With chemical weathering, what we're tending to do is we're dissolving the rocks away by some sort of interaction with either air or most commonly with water, such as rainwater or water in the ground or in rivers. This type of weathering is called chemical weathering. And one simple example of that would be if we had a layer of salt that can be a rock. We can just have layers of salt kind of laying in that stack of rocks that we have. That can get chemically weathered away by water, where the salt is essentially just dissolved. But the example we'll look at is one called oxidation. So with oxidation, this shows on not rocks, but on an old tractor, what's going on with oxidation. This tractor was constructed with iron, and that iron is undergoing oxidation from the rain that is falling in this area here. And the same thing can happen with rocks. There are many rocks that have a lot of iron-rich minerals in them, such as the basalt that covers the ocean floor and is sometimes exposed at the surface. And other rocks have even an iron type cement that's holding them together. All of this can turn rocks a reddish, rusty color when they're oxidized. So in order for oxidation to occur, it happens more quickly if there is some sort of acid like a sulfuric acid in the rain. And this was actually quite prevalent in the United States in the past. We can see this is a map of where acid rain was most prevalent in the United States about 50 years ago. And a lot of this was being caused by the heavy industry that was occurring in places like Detroit and Akron, Ohio, and Pittsburgh, Pennsylvania, and all these places that had a lot of heavy industry and manufacturing going on. They would put they would have emissions from their factories, which would go up into the air and cause the rain to become more acidic. And this was actually causing like die-offs of fishes in lakes in upstate New York and things like that back in the day. Things have improved, but all rainwater is a bit acidic, and this can really influence how rocks are both oxidized and how they're dissolved. So in this example here, we have two different headstones. This headstone is made out of granite, and it's doing pretty well. It's actually quite legible still, but we can see the headstone behind it, or even this headstone over here, is actually getting dissolved away by the acid rain. And this just naturally happens with limestone. The limestone is going to react with the sulfuric acid in the rain, and rain is always a little bit acidic, and it's going to slowly dissolve it away over time. So just like if we put a drop of hydrochloric acid on that headstone on the right, we will get a bubbly fizz from the carbon dioxide being produced. That the same sort of thing is slowly happening as the rainfall falls on this headstone here. Sometimes limestone is exposed at the surface of the earth. This is limestone here in an area in Ireland called the Burren, B-U-R-R-E-N. And this is showing how kind of smooth and glossy this limestone looks, because it's slowly being dissolved away by the rainfall in this area. And of course, if there's a layer of limestone underneath the ground, that water can trickle through from the ground level, go through the cracks, and drip through the cave, and it can actually dissolve an entire layer of limestone underneath the ground and form a cave system. So this is a layer of limestone here. This part has not been dissolved away, but of course all the empty space in this cave has been dissolved away. And we can also see that there are stalagmites and stalactites in this cave. So that the stalactites grow from the ceiling of the cave, and those look like kind of like icicles dripping down either the walls or the ceiling of the cave. And those are formed as the water drips through this empty space, and just like an icicle grows downward, it grows downward in the same type of manner. And on the bottom of the cave, there are the stalagmites. Those are the ones that are growing upward. It's dripping down from the ceiling, but as it drips onto the floor of the cave, it's building up these stalagmites. So we have an area here where first we had a solid layer of limestone. That limestone had a big cave formed in it because all of the limestone that was originally there was dissolved. But then as the water continues to drip through the cave, we get these stalagmites and stalactites being developed.